Welcome to the NSX Advanced Load Balancer Operations Workshop video series. My name is Juan, and in this series, we will continue to talk about understanding the NSX ALB architecture. In this part of the series, we will be talking about the following topics. Understanding the NSX ALB architecture, talk about the service engine groups, high availability modes, and data plane resiliency. First of all, let's talk about the HOL topology. This is the lab that you can always access by going to this URL. All the material that we'll be talking about today in this video is covered here. You can either follow along, pause the video, access the lab, and continue, or you can do it at any time at your convenience. Again, this HOL has two sides, and one of the sides, we just need to refer to one of the sides for all the exercises here. Now, first of all, let's do a service engine summary. These service engines are the lightweight appliances that handle all the data plane operations within AVI. The SE hosts the virtual services and require either direct or routable access to all the client and server networks that the virtual services touches. Now, the service engine, it's again pre-provisioned by the controller on a write access mode or by the administrator. The controller also takes care of placing the virtual service on that service engine, but the service engine is essential to the virtual service. And a typical deployment may have one or many service engines for different reasons. It can be redundancy, scalability, and for accommodating a large number of applications. Again, a service engine can serve multiple virtual services. The SEs are always grouped within the context of an SE group, which provides settings for high availability, scalability, and also act as an isolation data plane for different tenants. The service engine group exists to a group different settings that will be applied to all the service engines running on them. A service engine must belong to a service engine group. It cannot exist outside the scope of a service engine group and can only belong to one service engine group at any given time. Now, we just mentioned the service engine groups. Let's talk about what are them. It's a collection of one or more service engines and that share properties. It has a high availability mode, management network, where are those service engines placed in your management plane, and also can have multiple other settings like very specific to the configuration of the service engine, like CPU, memory, and disk allocations. As mentioned before, the service engine group provides a data plane isolation when different applications are mapped to different SE groups. There can be multiple reasons for which you would like to have data plane isolation. Could be an application that for security reasons has to be completely isolated from others. It can be because you have different tenants, or it can also be some mandate within your organization to have them isolated. They can be also for the scope of a service provider, right? Where you need isolation between the applications that run on them. So you can accomplish that through the service engine groups. A virtual service can be placed on a specific service engine group using the Advanced tab. We'll take a quick look in the UI and see how it looks. But essentially, there's an option to select what is the destination for that virtual service on the advanced settings. And the service engine group has config options based on the type of cloud, and also settings that have to do with the access or no access type. When you have a no access, those elements on the service engine group will look different. And this is one example of configuring a service engine group. So on this service engine group, we have to provide a name, and we select the high availability mode, right? You can see that there's a legacy HA and an elastic HA. There are two different modes for elastic HA that we'll discuss in just a moment. We have settings also for the BS placement, the BS placement modes, compact or distributed. We also have these specific numbers that we were referring in previously. Memory, CPU, and disk. These values will change from cloud to cloud. We're looking at an example that is from a vCenter cloud, and in that vCenter cloud, we can determine the specs for the VM. If we're talking about public cloud, this will look different again, because we cannot specifically go and select how much memory and CPU. We'll have to go with an instance type, and that's how they're going to be different. Now, let's talk about the high availability modes. But before that, let's just switch to the HOL environment and just go through the controller. Let's just log in, select the region A. Again, we're just not concerned about which one we are going. Any of the two regions will be the same. Again, we have a few things pre-deployed on this environment. But what we can do is go to infrastructure, right? On the infrastructure section, we have clouds. We discussed in the previous video, and we have a vCenter type cloud. And then we have service engines and service engine group. The service engine group, again, here we would have to select the cloud. There's only one cloud currently. There's only a default cloud. Therefore, there's only a default group. Every time you create a cloud, there's one service engine group deployed automatically for you. And we can see all those settings that we were just reviewing on the slides. We have the legacy or the elastic HA and the different options that we can configure. We have memory for caching, available memory for connection and buffers. The key takeaway here is that all these settings affect any virtual service placed on this service engine group. Remember that when we create a virtual service, we have the option to select what service engine group it will be placed on. We cannot go and directly tell it, place it on a specific service engine. It has to be done on a service engine group. Let's go back to the slides and talk about what do we mean by high availability modes. The AVI provides three high availability modes. The first two, elastic HA, combine scale-out performance and high availability. And we have two modes. We have N+M, which is the default, and we have an active mode. On the other side, we have the legacy HA active standby mode. The reason for this HA method is to replicate what we have seen on a traditional load balancer, where you have one service engine or one appliance in this case that is active, and the other one is just in standby mode. The elastic HA N+M mode is recommended for applications where two conditions apply. The performance by an application can be delivered by a fraction of one SC capacity. Therefore, each virtual service is typically placed in a single VS, right? Again, that service engine in general can host multiple virtual services. And in this mode, the virtual service performance can be delivered by a fraction of that service engine. The second, the applications placed on this type of HA tolerate a brief outage amounting to the duration of placing that VS on the buffer C and plumbing the network. When we say plumbing the network, what we mean by this is creating the network required for the virtual service to reach the backend servers. Now, there's a brief outage, and the reason for that is because when one of the service engine fails, the controller has to make that decision and place the configuration of that virtual service on a different SC. Now, if your group has a buffer service engine already deployed, that time is minimized. Now, in some cases where you have where you don't want to have those service engines idle, you will have to account for the amount of time that the controller takes to talk to the cloud through the cloud connector, talk to the compute engine, for instance, vCenter, and create a new service engine where you can place the virtual service. Now, on the other hand, we have an active-active mode, and that is more suitable for mission-critical applications which need no interruptions. And talking about the active-active mode, the virtual service placed on this mode is going to run at a minimum in two service engines. One service engine will be primary, and the other ones will be secondary. And anytime there's a failure, you'll have at least one service engine that will take over and continue with the traffic. When you have an active-active mode, the service engines all participate in the traffic for that virtual service. Now, for the Elastic HA, the default is this mode, and each VS is typically placed in just one SC. So let's explore some of the settings that we can configure here. The moment we select N+M, then the placement algorithm is set to compact. We'll explain this in just a moment. And we have to define the number of the virtual services per service engine. This is a maximum. And this is how we control how dense we want to have those virtual services. Again, according to a sizing exercise, you can determine what is the throughput and other performance metrics that one single EC can deliver, so you can make the decision about how many virtual services you want to run per service engine. Now, in this N+M mode, N represents the maximum number of SCs required to place the VSs in the group. M represents the aggregate capacity of the SC group to handle M SC failures. And that's where we sometimes we talk about the buffer and how many service engines we want to have idle, ready to take over when one of these events happen. And we have that section for the buffer service engines. Now, let's explore an example of how does this work. We have 20 virtual services configured in a service engine group. Because we have configured the maximum of BSs to be 8 per SC, that leads us to have N equal 20 divided by 8. We're going to need 3 service engines in order to accommodate those 20 virtual services. Now, if we want to have M, a buffer of 1, then we're going to add 1 service engine to those 3. In total, we have 4 service engines required in the group to deliver the services for those applications. In this case, we can see this diagram. Prior to a failure, we have 4 service engines, and we have 8 slots on each of the service engines. We have distributed the workload. Each virtual service is represented by a slot here. And then in the event of a failure, by doing this design, we will guarantee that we can tolerate one failure and then distribute the virtual services on the remaining service engines. Again, when is this suitable? N+M is recommended for the following conditions. When we have virtual services that can be delivered by a fraction of the service engine. Again, typically, those service engines can host multiple virtual services, but in this mode, the virtual service will only run in a single SE. And again, the applications tolerate a brief outage, depending on how many buffer service engines you want to have, and then in how long are you expecting the controller to be able to create a new service engine from scratch. That will determine when is this recommended. Again, if you want to have, you don't want to waste resources, you don't want to have anything sitting idle. Again, the compromise there is that the service engine, the virtual services will take more time to be placed on a different service engine upon failure. The pre-existence of the buffer service engine speeds up the replacement, as we just mentioned, and will give you a quicker recovery time. Now, elastic HA active mode. The controller places each virtual service in more than one SC, and that's specified by the minimum scale per virtual service parameter. I'm going to take a quick look in the UI in just a moment. Again, we have selected here elastic HA. The moment we select this, then it goes to distributed. This is the default placement mode that we'll explain in just a moment. And the default minimum for scale out per virtual service, it's 2, I'm sorry. And here's what we can change it. Now, this minimum settings means that it has to be above 1. Otherwise, we'll have an N+M type of HA. That ensures that every virtual service is scaled out across multiple SEs, regardless of the capacity requirements. This increases the potential, increases the potential capacity of the application, but it minimizes the impact upon failure. If we have the virtual service running in multiple service engines, when one of them fails, we know that there will be at least one service engine that will continue to deliver the traffic to the backend servers and replying to clients. Therefore, there's no impact. Again, the performance of the virtual service can be impacted if the total expected performance cannot be delivered by one single service engine, but there's going to be no interruption for the clients. And the maximum setting allows us to set a boundary for how many we want to have. By default is 4, and the maximum is 4. There are good reasons for not wanting to go beyond 4 that we will explain later on the following video. Now, before we go into an example, let's take a quick look in the UI. So we talk about the basic settings, right? And then this just switch to, we're still on N+M. Now, these are the different settings that we can configure. We can set the virtual services per service engine, and we can have also a limit on the number of service engines. This is important when you're creating on an environment that it's a write mode. For instance, vCenter with write mode will create as many service engines as the controller thinks it needs. Now, if you want to put a boundary in and limit the amount of service engines so they don't go crazy upon deployment, then you can set a maximum. Now, on the advanced tab is where we have the amount of buffer service engines that we want to have. The maximum of service engines on the group it also includes the buffer service engines. So this is not in addition to the number that you have configured on this side. It's the total number. So we have here by default is 1. And then because we're an N+M, it goes to scale per virtual service to 1. And again, maximum is 4. So at least it's going to run, that's the minimum. It will run in one service engine. Now, if we go back and we select active, then it goes to distributed. Then the numbers change here. And then if we go to advanced, automatically, there are no buffer service engines. We don't need buffer service engines right now because we have redundancy. We have the virtual service running in more than one. So it goes automatically to 2. The maximum of 4 is still maintained. That will guarantee that we're going to place it in 2 service engines. Let's just go back to the presentation and go through an exercise of an active. In this case, we have 5 virtual services configured in the SE group, and we have a max per SE set to 3 and a max number of service engines set to 6. So we're not going to have at any point in time more than 6 service engines. Now, this is going by the defaults. The minimum scale per VS is set to 2, and the maximum is set to 4. So on the left-hand side, we have the first, the initial configuration for the service engines. And we have BS3 that is placed on 3 service engines. All the other virtual services are placed in 2. Now, if we lose SE3, what's going to happen? We already have BS3 running in 2 and BS2 running on a couple of service engines. So there's no impact, right? They continue to run perfectly fine. Now, what the controller will do, if it loses communication or it cannot reach that service engine, it determines that the service engine is down. After a period of time, it's going to recreate or deploy a new service engine in this case. And once that service engine is ready, then it's going to place the BS3 and BS2. Now, because BS3 and BS2 were already running on different service engines, there's no impact to the traffic. Now, when do we recommend this? This is recommended for mission-critical applications where virtual services must continue without interruption. Now, as previously mentioned, there can be some impact in terms of the performance if the total capacity for the virtual service in terms of performance cannot be delivered by a single one. But at least you can run on decreased capacity, but you're still running. There's no interruption. Now let's talk about the active standby mode. In this case, there are 2 SEs configured. Active SE carries all the traffic for the VSs placed on it. And the other SE pair is just on standby. It doesn't carry any active traffic. Now, during takeover, if there's a failure on the active one, the standby takes ownership and all the floating addresses. So the VIPs, the SNAT IP, all that moves to the standby. But on the regular conditions, it's not carrying any traffic. This is useful for replicating the traditional sense. Some customers might like to see the configuration initially, exactly as they have been using with other traditional solutions, before they can move on into realize the advantages of using the other 2. And this is just a quick diagram showing that during the regular operations, it's completely on standby. Let's just quickly move to the UI and give an example and see how the parameters change when we select active standby. Now, if you select active standby, this is the maximum number of service engines that you can have in the group. There are 2. There's no need. You can only place every virtual service in one. So it's pretty rigid. So you have two service engines, but at the same time, you know what to expect in terms of how many service engines you're gonna have. The moment we switch that, let's take a look. We don't have any option for compact or distributed for the placement. And under the advanced, we don't have anything for the number of scale in, scale out parameters. There's nothing for that. And that's because of the selection that we have made. So all those values make sense in the context of what is the HA mode that we're selecting. Okay, let's just go back to the presentation. Okay, let's move on. And let's talk about the compact versus the distributed placement. Now, when we have selected N+M, let's highlight that this is the compact. By default, it goes into that. And what we're going to be trying to do in compact placement is to use the minimum number of SEs required to place the configured virtual services. When we have selected a different, we turn it on, then AviVantage will try to use as many as required. Again, when we switch to active, it will be distributed. And then in that mode, we'll try to use as many service engines as possible. Again, remember that there's a setting on the service engine group, and that setting limits the number of service engine in total that you can have. So you cannot go over that number in any situation. So we always put a cap on that value. Compact placement is on for N+M, and distributed is on for active. Again, this is the number that will always limit the maximum number of service engines. Let's go through an exercise and see how that compact placement on N+M affects the placement of the virtual services. We have a maximum number of service engines here that is set to 8 for this N+M SE group. We have 8 virtual services that are creating in sequence. Because we have BS1, we have the compact mode, right? So we start deploying, and they're all configured in sequence. So we're gonna start creating or trying to put as much as we can on the least amount of service engines. So we started creating VS1, and VS2 goes into a second SE, and so on and so forth until we reach VS8, right? We haven't reached the amount of service engines, but because of the compact placement, we try to make use as much as we can based on the parameters that we have defined on the service engine group, trying to make the most of that service engine. In this case, when VS1 is placed, then automatically that creates a new service engine, and we continue. Then after this point, the behavior kind of changes, right? We just mentioned that when we have the compact placement on, all VSs3 through VS8 are created on the pre-existing service engine. Now, the difference is when we have distributed placement on, we try to put VS3 and VS4 not in the same service engine. We try to create more. So in this on the picture at the bottom on the right hand side, you can see that we create VS1. There's one service engine created, VS2 on a different service engine, VS3 on a third service engine, and VS4 on a fourth service engine. Because we have a limit in this case, we're gonna stop creating service engine, and VS5, 6, 7, and 8 go into the existing ones. So we never go beyond the limit that we have configured, but we try to use as many service engines as possible. Again, this is the impact of using that if we have compact placement, because we can also select compact placement for active-active. So by default it's on, but we could change it. When Service Engine 3 encounters a failure, the controller delays the placement of BS2 and BS3 until a new Service Engine SE7 has spun up. None of the existing SEs were chosen to place BS2, and BS2 fulfill the distributed placement logic. Again, if you look at this in a simpler way, when we have active-active, the reason for having a distributed mode is because those virtual services are going to be placed in more than one. By definition, they need to be running on multiple service engines. So you want to have as many service engines as you can, so you're distributing the workload, and you have those virtual services in multiple places. When you have compact, then potentially that could affect a larger number of virtual services. And because of the active-active mode, this is for mission-critical applications, you want to have the workload spread out as much as possible on your service engine group. And let's talk about some final questions before wrapping up the module. What is the HA mode of a virtual service? Again, that comes from the service engine group in which it's placed. So every virtual service goes into a service engine group and inherits the HA mode for that. And that's what's going to determine the data plane resiliency for the virtual service. What SCs are handling traffic for a virtual service? This is the other common question. And in order to determine that, what we will have to do is when we go to the virtual service and hover over the mouse to the name, this is going to tell us and how many is running. So you can see here on the service engine section that is running on service engine that's, its name ends in FA, that's the primary, and BN, because it doesn't have the primary label, it's a secondary SE. That's going to tell us that this service engine, that this virtual service has been placed on a service engine group with active-active configuration. And this is how we're going to display that. And then if we click on the any of these service engines, that is going to take us to the service engine section. So in this example, we have clicked on the first service engine, and that takes us to the menu of the service engine. And then that is going to tell us what service engine it belongs to. Here it is. And this is how we determine which SEs are handling traffic for a virtual service. This is just an overview. In the HOL, this is all simplified. There's only one service engine group. And in this example, because you have the drop-down, you have multiple clouds within each cloud, you're going to have multiple service engine groups. And you can have, in this case, they're not all active-active. You have some M+M and one active-active. So you can mix and match within your cloud. And you can configure different HA capabilities depending on the applications running on that cloud. Now, let's just quickly switch gears and go to this example. Now, let's take a look at one of the virtual services running on this lab and see where it's running. So we have these DNSBS. So let's just click on it. Remember, when I hover over the name, then it tells me that it's running on this service engine. This service engine, again, it has a prefix in the name. And if you don't know if you recall, but there is a section on the service engine group where you can set that naming convention. You can put a prefix and help you to identify easily the service engine virtual machines within your environment. or depend if you're using public cloud, you can always configure that too, or on-prem. It's an easy way to identify those. Now, if I click on this is only running in one as a primary. I'm guessing that this is an N+M. We'll confirm that. So the moment we click there, we go directly to the service engine. If we wanted to see performance information, is automatically displayed here. This is just a test environment, so don't expect to see a lot of traffic or resource utilization. These are small, that's why it's maybe 35%. It's just because it's a small virtual machine, so there's not a lot of resources to left for the applications. And if I hover over the name again, it's going to tell me some basic information. It's telling me that the management IP is this one. This is the port group that is this is the vCenter Cloud. This is the port group that is running on, and this is the physical host that is running on, and is part of default group. There's only one default group, and I bet it's using the default, so it's an N+M. We'll take a look in just a moment. So that's how we take one VS. This is especially useful for troubleshooting. If we were to know exactly where the traffic is coming from, what IPs are involved, all that information, we can just start drilling and jumping from menu to menu until we find exactly what service engine is participating in the traffic. Again, if we were to go to the service engine group, there's only one cloud. It's a default cloud and is N+M. Okay. I hope this information was valuable. If you want to play on your own, feel free to check again the hands-on lab and test the configurations and the concepts explained here. Thank you.